Okay, geometry, we are going to start surface area and volume, which has to do with three-dimensional figures. And there's going to be three different videos for you to watch today because we're going to go by shape or classes of shapes. So we're going to talk about spheres first, and that's why I have this picture up because there's a bunch of examples of spheres right here. Then the second video will be about prisms, and the third video will be about cylinders. So you're familiar with a sphere. There's a bunch of examples right here. There are parts of a sphere that you need to become familiar with, shown in the center picture right here. There's a center of a sphere. You can see a sphere has a radius, has a diameter, and a great circle. So a great circle is like the equator. It's the largest of the circles that could go around a sphere like that. So let's go ahead and start there with spheres. Write some of this stuff down. All right, let's start with the definition of a sphere. So a sphere is simply a set of points in space, meaning 3D, that are equidistant from a center point. You might think that that definition is pretty familiar because if you just take out in space, it's the definition of a circle. So a circle is a set of points that are equidistant from a center point. But if we put that in space, then we can move in all directions, not just in 2 dimensions. Okay, the parts of the sphere are as follows. The radius, so one example of a radius in this picture would be like O to B, or even O to E. That's a sphere, a radius of the sphere. So segment OB or EO. Those are some examples of radii. The center is O. A great circle has a center at O. So any circle whose center is O. So for example, this circle right here is a great circle because its center is O. But this will be a little hard to see, but hopefully I can make this visualization here. This circle that would be right here is not a great circle because its center would not be O. Any circle whose center is O, and is on the surface of the sphere, is called a great circle. And then a hemisphere, you should know that as half a sphere. Just like we can split the Earth up into northern or southern hemispheres, eastern, western. Okay, so we're going to talk about surface area and volume of a sphere. And what you will find is that if you were to, for example, take an orange and peel it, the peel of the orange is the surface area of that sphere-shaped fruit. And if you were to draw 4 great circles using the orange, so like I'm tracing around the outside of the orange, so all of these circles were the same size, and we took that sphere, we took the peel off of it, and we placed it in these circles, those circles would all be filled up perfectly. The area of this circle, of course, is pi r squared. The area of this one is pi r squared. This is pi r squared. This is pi r squared. So the surface area for a sphere, we'll call it SA, is 4 times pi times radius squared. The volume is 4 pi times the radius cubed, all divided by 3. So let's go ahead and try that with a sphere, this example right here. 6 is the radius. So let's calculate first the surface area and then the volume. So the surface area is 4 times pi times the radius squared. Radius is 6, so I'll put a 6 in place of radius. All right, go ahead and put this in your calculator. So let me show you, if you don't remember, where that pi key is at. So we would do 4 times, the pi key is right above that division sign, but it's yellow on mine, so I have to press the second key. There's the pi key, and then times 6 squared, and press enter. Let's go ahead and round to the nearest hundredth for this entire unit. So 452.39, and this is area. So we want our units in squared units. So it's feet squared. All right, now let's take a look at volume. So volume equals 4 times pi times the radius cubed. I can't stress that enough. Everybody that misses this misses it because they put a square instead of a cube there, but it's radius cubed. And then all divided by 3. So in my calculator, I'll do 4 times second pi times 6. Now if I want to do cubed, it's the same button as the pi button, but you don't press the second first. We call that the caret button. So you do this little caret, and that lets you put any exponent in there. A cube to the 4th power, to the 1/2 power, whatever you're putting it, whatever power. So I'll put it to the 3rd power, and then I'm going to divide by 3. And my calculator does order of operations for me, so it's going to take that first 3 into the exponent and then divide everything by 3. It's not going to give me an exponent of 1. It kind of looks like 3 divided by 3 in my calculator, which is 1, but it's not doing that. It follows the order of operations. Alright, so we get a volume of 904.78, and this time the units are cubed, because volume is how many cubes you can fit inside of something. Okay, that's spheres, and the next video you watch is going to be prisms.